This is our Chapter 3 test review. This particular review is broken down by lessons. So this first part here, which is 5 questions total, is all on lessons 3-1, graphing linear equations, and 3-2, solving linear equations by graphing. Number 1, determine whether y equals 2x minus 1 is a linear equation, and if so, write the equation in standard form. So remember, we have a linear equation whenever we have an x or a y or both, and they are not being multiplied together. They're either being added or subtracted, or they can be on 2 different sides of the equal sign, and neither one of them have an exponent, right? So here, that is the case. So this is a linear equation, so we're gonna write yes. And then to get it in standard form, remember, is ax plus by equals c, where a, b, and c are just numbers. Doesn't matter what they are, there might not even be numbers. But the idea is just that we have x and y together on one side of the equal sign and any other numbers by themselves on the other side of the equal sign. So here, I have a y on one side and a 2x on the other. I need to get them both on the same side. Remember, I had 2 rules about a. A cannot be negative and it cannot be a fraction, right? So here, it's not negative, it's not a fraction. I'm gonna leave it alone. So I'm gonna move y over here. How am I gonna do that? I gotta get rid of it over here first, right? So I'm gonna subtract y from both sides of my equal sign. It's gonna cancel here, so I get 0 equals 2x, and then I just subtracted y, minus y, and I still have this minus 1 on the end. So I have ax, by, b is negative 1, 2x plus negative 1y, and then I need equals a number. So I got to get this negative 1 on the other side of my equal sign. So I'm just going to add 1 to both sides, right? So 0 equals 2x minus y minus 1. Add 1, and I get 2x minus y on one side of my equal sign and 1 on the other. And of course, I want the 2x minus y to come first, right? So I'm going to write 2x minus y equals, and I had a positive 1 here, so positive 1. There's my equation in standard form. A is 2, b, the number in front of y, is negative 1, and c is 1. Okay, number 2, multiple choice. What is the y-intercept when 3x minus 2y equals negative 6 is graphed? The x and the y-intercepts come whenever you plug 0 in for the other variable. That's it. So if we're looking for the x-intercept, plug a 0 in for y and solve for x. If you're looking for the y-intercept, plug a 0 in for x and solve for y. So I'm going to say 3 times 0, I'm looking for the y-intercept, 3 times 0 minus 2y equals negative 6. 3 times 0 is just 0, so it goes away. So I get negative 2y equals negative 6, and I want y by itself, so I need to divide by negative 2. So I get y equals negative 6 divided by negative 2 is positive 3. A negative divided by a negative is a positive. So I get y equals 3. Or you could write the y-intercept as 0, 3. When we plug a 0 in for x, y is 3. Either one of these is correct. Okay, then we have number 3. The distance d in, the distance d in miles that a car travels in t hours at a rate of 58 miles an hour is given by the equation d equals 58t. Total distance equals 58 miles per hour times however many hours you traveled. What's the best estimate of how far a car travels in 7 hours? Okay, so like mental math. This 58 is almost 60. So in my brain, instead of multiplying 58 times 7, I'm going to multiply 60 times 7. What's the best estimate of how far, which is distance, a car travels in 7 hours? D equals about 60 times 7. Of course, 6 times 7 is 42. So 60 times 7 is 420. And distance, it tells us, was in miles. So that's 420 miles. Okay, and then we have number 4. We have to graph, and it gives us a graph here. So our equation we're graphing is 3x minus y equals 3. To graph, this is in standard form, ax by equals c. To graph this equation, we have to find the x and the y intercepts. So we're going to plug a 0 in for x and solve for y, plug a 0 in for y and solve for x, and plot them on our coordinate plane. All right, so 3, doesn't matter which one you plug 0 in for first, because you got to do it to both. 3 times 0 minus y equals 3. 3 times 0 just goes away. Negative y equals positive 3. So positive y has to equal negative 3. You just either multiply or divide both sides by negative 1 since there's a negative sign in front of y. So there's our y intercept. So on my y-axis, I'm going to come here to my graph, and I'm going to go down to negative 3, 1, 2, 3, and put a dot. And then for my x-intercept, I'm going to take the same equation, and I'm going to plug a 0 in for y and solve for x. If you're looking for the x-intercept, you can't plug a 0 in for x. You want to find x, so you plug a 0 in for y to get rid of it. 3x minus y, which is going to be 0, equals 3. So minus 0 is just nothing, right? So we get 3x equals 3. Divide both sides of our equal sign by 3, and x is going to equal 1. So on my x-axis, I'm going to go over to positive 1. And once I have 2 dots, now I can just draw a line through it, right? Ooh, that was not a straight line. I hope your line's a lot straighter than that. So that's about what it looks like, and we can put our intercepts down here. Y equals negative 3, x equals 1. Good. If you have questions on that, let me know. And then the last one here, number 5, is just to solve. Solve 3x minus 45 equals 0. Remember, this is an equation where when we're solving it, we want to replace 0 with y, right? So it would be 3x minus 45 equals y. That's our equation. And then the answer is the x-intercept when y is 0. Well, that brings us right back here, right? So here's our equation. When we solve it, we're finding the x value when y is 0. So we get 3x minus 45 equals 0. To get x alone, I'm going to add 45. So this negative 45 cancels, and I end up with 45 over here. And then I'm going to divide both sides by 3, and I get x equals 15. So on my answer key, oh, oops, I put this answer for the graph here. Sorry, my fault. Hopefully you pay better attention than me. X equals 15. You didn't have to write these in. I did extra work. Okay, all you needed for 4 was the graph, not the intercepts. That was just your work. Number 5 should be x equals 15. Okay, and then the next part is lesson 3.3. I am breaking this down into 2 videos, so we're going to finish here, and then there'll be a separate video with the rest of chapter 3 review. All right, for 3.3 it was all about slope, right? Rate of change in slope. So find the slope of a line passing through each pair of points. Remember, our slope is, where's my black pen? I don't know where it is. Okay, slope here is y minus y over x minus x. That's our slope, right? It's y, remember y, our y-axis goes up and down, and our x-axis goes side to side. So it's our change in y over our change in x. So it's rise, how much we go up or down, over the run, how much we go to the side. That's our slope, rise over run. All right, so find the slope of the line. Here we have 2 sets of x's and y's. Does not matter which order you start with. So I have to start with y on top, but it doesn't matter if I start with 8 or 6. So I'm going to do 8 minus 6 over, and since I started with 8 on top, I have to start with its partner first on the bottom, 5 minus negative 4. I could have started with 6 on top, if I did 6 minus 8, and then I would have just had to start with negative 4 on the bottom, negative 4 minus 5. Either way, I'll get the same answer. Okay, so when you minus a negative, it becomes a plus. 8 minus 6 is 2. 5 plus 4 is 9, and I can't simplify that anymore, so my slope is 2 over 9. Okay, number 2, same exact thing. We're going to use this for our slope. y minus y, the second number in each ordered pair is always y, 4 minus negative 3, over, and since I started with 4 on top, I start with 9 on the bottom, 9 minus 5. When I minus a negative, I have a double negative, I make it a plus. 4 plus 3 is 7. 9 minus 5 is 4. And when you're talking about slope, you do not change this to a mixed number. You keep it as an improper fraction, 7 over 4. This tells us that my graph, my line when I graph it, is going up 7 over 4. If I changed it to a mixed number, 1 3/4, I don't know what the rise over run is. You gotta keep it this way. So 7 over 4, done. Number 3, multiple choice. Which value of r gives the line passing through blah, 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 a slope of 3 over 2. So we're gonna set it up the exact same way, right? I'm gonna do it on a separate extra sheet of paper to give myself room. Sorry, I didn't get said sheet of paper. All right, so we're gonna do y minus y, 2 minus negative 4, over, I started with 2 on top, so I gotta start with 3 on the bottom, 3 minus r. But the difference here is that that tells me my slope. I don't know what r is, but I know what the end result is, 3 over 2. So it equals 3 over 2. So now I just simplify and solve for r, right? Minus a negative becomes a plus. 2 plus 4 is 6. I can't simplify 3 minus r. And this stays 3 over 2. And then I have a proportion here. When you set two fractions equal to each other, it's a proportion. So you cross multiply and you set the answers equal to each other. So 6 times 2 equals 12. 3 times 3 minus r. We have to simplify and we're setting those equal to each other. So I'm gonna distribute. 12 equals 3 times 3 is 9. Bring over my minus sign, 3r. I'm trying to get r by itself, so I need to get rid of this 9 first. 3 equals negative 3r, and then get rid of this negative 3. This is not r minus 3, so to get rid of this, I'm not going to add 3. That doesn't get rid of it, right? This is negative 3 times r, or r times negative 3. So to get rid of times negative 3, I have to divide by negative 3, and then do the same thing here. So these cancel. 3 divided by negative 3 is negative 1. So r has to equal negative 1. Is that one of my answer choices? Yes, it is. So I just write B here. On the answer, sorry. Okay, number 4, determine whether the function is linear, right? Linear or not linear, right? It's linear if it has a constant rate of change. So if the amount that we're changing for each line is the same. Okay, so for x's, to get from here to here, I subtracted 2. To get from here to here, I subtracted 2. To get from here to here, it looks like I subtracted 2. And to get from here back to here, did I subtract 2 again? No, I added 2. So since I'm not doing the same thing over and over, this side's the same, this side is not the same. So this is not linear. We have to be adding or subtracting the same thing over and over in both columns for it to be linear. Okay, and then number 5, in 2004, there were about 275 students at Delaware High School in the band. In 2010, that number increased to 305. Find the annual rate of change in the number of students in the band. Well, we have two pieces of information here. We have the year and the number of students. Time always goes first. It's always our x value. It's always listed first. So in 2004, there were 275 kids in band. In 2010, there were 305 kids in band. So we're going to find the slope, right? Y minus y over x minus x. So y minus y, I'll do the bigger minus the smaller. 305 minus 275 over 210 minus 204. 305 minus 275 is 30. 210 minus 204 is 6. and 30 divided by 6 is 5. So what does that mean? It says find the annual rate of change in the number of students in the band. Well, there's 5 students every year, right? Which means they went up 5, they increased by 5 students. If it was negative, they would have decreased. It's positive, so they increased 5 students every year, every 1 year. 30 students every 6 years, 5 students every 1 year. If you have 30 students over 6 years and you want to kind of divide it out evenly, 30 divided by 6 is 5 students per year. Okay, let me know if you have questions and make sure you stay tuned for part 2.